Hi, welcome back. So today we will go to the last section of this particular introductory chapter before we enter the real SACE mathematical methods. So which is introducing all the important functions. So before I enter that particular section, just slight reminder from the last video. So basically, from the last video, I mentioned that for the y-coordinate transformation, the function transformation is more straightforward. So what do I mean is that basically if you do the stretch or compress and then you do the translation for the y-coordinates, then it will follow exactly what the number gives you from that particular set of function transformations. But if it is along the x directions, what you would actually want to do is to do the translation first and then do the stretch or compression. So the y coordinates are totally sort of like different from the x coordinates. So this is the only thing that you need to remember. So perhaps I will just write down this one reminder over here. Basically, you need to be mindful that if it is consecutive y coordinate transformation. So what do I mean by that? So you just look back at the example from the last video. So basically, this particular example is one example of consecutive y direction kind of transformation. So you look at the first one. So if you perform the stretch or compress first and then you do the translation, you find that the factors are the same, which is 2 and 2. So it means that for consecutive y coordinate transformation, what I would recommend you to do is to always do the stretch or compression and then only you do the translation. So the other thing that you need to take note of is if let's say you have consecutive x coordinate transformation. So if you look at the example from yesterday, it is always recommended for you to do the translation first, then you do the stretch or compression so that your translation factor or your stretch or compression factors stays the same. So you will do the translation first, then you do the stretch or compress. So this is a rule of thumb for you to sort of like remember if you don't want to do all the steps. Of course, you can, for example, for the consecutive x coordinate transformation, you can always do the stretch or compression first, then you do the translation. But as I showed yesterday, if you do in that particular order, you always need to fix this particular factor. So you need to be extra careful about that. Similarly for the y coordinate transformation. So if you follow exactly this kind of order of transformations, then the stretch or compression factor or the translations, all the numbers will remain the same as what is given in the question. So this is the only thing that I need to stress. So now let's look at some important functions for SACE mathematical methods. So of course, the first one will be what we already kind of familiar, but I would say that um, so previously you should have learned about quadratic equation. So quadratic equation is something like ax squared plus bx plus c. So we know that this is a function. So polynomial basically is something more general in the sense that if let's say you are given a function, so polynomials basically means you power up to n until let's say okay, let me redo the notation. So let's say I start with a power n, sorry, a subscript n, and then x power n. So a subscript n minus 1, x power n minus 1, and then so on until a x. So it will be a1 x1. So x power 1 usually we don't write it, and then the last term will be a0. So this is what we call as a polynomial of degree n. So the degree means the highest power of your function, polynomial function. So in other words, for quadratic equation, that will be a polynomial of degree 2. So perhaps I move this whole thing to the top. So yeah, basically you just need to know this. And of course you need to know what is quadratic equation. Sorry, perhaps I should put function. So what is quadratic function? Basically this will be fx equals to ax squared plus bx plus c. So specifically for quadratic equation, you actually need to know all the details. Like for example, how do you perform, how do you factor the quadratic equation? How to factor a quadratic equation. So there is this direct way of factoring, and then there is what we call as completing the square, and then there is what we call as using the formula. So let's try one example. So let's say you have x squared plus plus 2x minus 3 equals to 0. So if you want to factorize it directly, the method that I usually use is drawing the cross. This thing here, x squared minus 3 here, then 2x over here. So as long as you make sure that this particular term, the highest power term, is positive, then you can read. So the method that I learned is that basically you need to make sure this is positive. Then reading from these two sign plus minus, you will get plus minus. So then you just figure out how do you get 2x when you sum them up together. So in this case, this will be 3, this will be 1. So over here you have 3x, over here you have minus x. So when you sum 3x minus x together, you get 2x. So this particular quadratic equation has the factor x plus 3, x minus 1 equals to 0. Okay? So this is how you would factorize the quadratic equation directly. So this is factorized directly. Now I'm going to show you how to do the same equation by completing the square. So completing the square, you start with x squared plus 2x minus 3 equals to 0. So the way that I'm doing right now, I will use it later on to derive the quadratic formula. So it will be slightly different from perhaps what you have learned before. Okay, so usually when people do completing the square, they will move the minus 3 to the right hand side, and then they will start doing the completing the square. But in this case, I just keep everything on the left hand side. So you just look at plus 2x. So basically you need to add a term which is half of this number. So in this case it will be 1, and then you square it. When you add one term, you need to minus one term, so that left side equals to the right hand side. Then you write down minus 3 as usual. So the first 3 term, x squared plus 2x plus 1, is actually just x plus 1 squared. And then you have minus 1, minus 3, so minus 4 equals to 0. So then you have x plus 1 squared equals to 4. So if you were to carry out the calculation, so you square root everything, x plus 1 equals to, so when you square root the right hand side, you need to add plus or minus term. And then finally, what you would get is the roots of the equation. So it will be 2 minus 1, which is 1, or minus 2 minus 1, which is minus 3. So if you compare the answer as above, you find that it is the same answer. So that's how you do completing the square. So now how do we derive the formula? So let's look at the formula. So we begin with ax squared plus bx plus c equals to 0. So this is the most general quadratic equation that you can write. So what you can do is to take out the a, and you know that only the first and the second term are somewhat important. So you just factorize the first and the second term. So you have b over a, x plus c equals to 0. Then the next step is to half the second term, the second coefficient, and then square it. So it is b over 2a square minus b over 2a square plus c equals to 0. Then you know that the first 3 term inside the bracket can become x plus b over 2a square. So then you square the minus b over 2a. So you get minus b square over 4a square. Sorry, I'm using a square bracket. Plus c equals to 0. So now multiply your a inside. So you have something like this. So now you start to move the minus b squared over 4a to the right hand side. So a multiplied with x plus b over 2a square equals to b squared over 4a minus c. So now I do this particular multiplication. Then you have b squared minus 4ac divided by 4a. So now you bring the a on the left hand side to the right hand side and then do the square root. So what you have is x plus b over 2a equals to, so I bring the a to the right hand side first. So by right you should have b squared minus 4ac divided by 4a squared. Then I perform the square root. So once I perform the square root, remember to add the plus or minus sign. So this is the end result. So for a square, you can square root it. So in the end, you have x plus b over 2a equals to plus or minus square root of b squared minus 4ac. So I do the square root beforehand, 2a. Now you finally move everything to the right hand side. So x will be equals to minus b plus or minus b squared minus 4ac divided by 2a. So this is how you would get your quadratic formula. So this is your quadratic formula. Basically, you derive it based on completing the square. So of course, the first thing that you need to know for quadratic function or for quadratic equation is to know how to factorize it all three ways. Then the second thing that you need to know for specifically for quadratic equation is how to sketch the graph. And the way you sketch the graph of quadratic equation or quadratic function this also relates to the following. If let's say b squared minus 4ac is greater than 0, b squared minus 4ac smaller than 0, and b squared minus 4ac equals to 0. So what are the differences? So if let's say let's say your a is greater than 0, you know that this is a U-shaped graph. So this particular quadratic equation corresponds to b squared minus 4ac greater than 0. So if let's say you have something like this, when it is just touching your x-axis, so we know that this is b squared minus 4ac equals to 0. And the last one, if let's say your quadratic equation does not touch at all, then this will be b squared minus 4ac smaller than 0. So this is only true when your a is greater than 0. So I should set the caveat. So over here a is greater than, so over here a is greater than 0, which is a positive number. If a is, sorry, a is greater than 0 in this case. If a is smaller than 0, then your quadratic equation will become an n-shaped graph. And basically, you can also divide into 3. It touches your x-axis at 2 points when b squared minus 4ac greater than 0. When b squared minus 4ac equals to 0, it only touches your x-axis at 1 point. And when b squared minus 4ac is smaller than 0, it doesn't touch your x-axis at all. So this b squared minus 4ac correspond to how many intersection points you have for the graph with the x-axis. Okay. So that is another thing that you need to know. And then basically I sort of explain everything that you need to know for quadratic function. So now in general, so this will be in general. If let's say you have a polynomial function with n, with degree n, sorry, we will have at most n roots. So if it is a polynomial of degree 3, for example, ax cubed plus bx squared plus cx plus d, the shapes that you can have if let's say a is greater than 0, so you might have something like this. So this particular shape, you intersect at most 3 points. Sorry. So perhaps the next section, sorry, the next video, I would also show you how to properly use the TI-84 because that will be very important for you as well. And that particular calculator has a graph sketching function. So this will sort of like offload a lot of things that you need to memorize for your exam. So if let's say you are intersecting at only 2 points, it means that there is this one repeated roots. So this will be intersecting 2 points. Or you can just intersecting at 1 point. So this will be intersecting at 1 point. So of course this is a greater than 0. You can also have a smaller than 0. The reason why I don't really show what happens when a is smaller than 0 is because you can simply just apply your function transformation, capital A. If let's say it is a -1, what you need to do is to do a reflection on the x-axis with respect to the graphs that I draw over here. So if let's say a is smaller than 0, originally it is a U-shaped graph. So what you need to do is just reflect it on your x-axis, and that's it. You get the more or less same results. So what happens if let's say you have ax to the power of 4, bx power 3, cx power 2, dx, and then e, and a is greater than 0. You actually go back to more or less like a U-shaped graph. But you need to remember that at most you can intercept your x-axis at 4 points. So this is the most general shape for a polynomial function of degree 4, whereby at most you intersect at 4 points. So you can experiment out and then you try what happens when you have a polynomial of degree 5. So what is the shape? You find that it is more or less the same as this particular S-shaped graph again. So in general, whenever you have polynomial of odd degree, it always looks something like S-shape. Whereas if let's say you have some polynomial function of even degree, the shape will be more or less looks like U shape or N shape. So that's what I'm trying to tell here. So more or less for the first type of function, which is the polynomials, you need to know the basics of all the shape of graphs. And specifically speaking, for quadratic function, you need to know how to factorize using all three methods. And you need to know how to sketch the graph. How does the graph looks like, and so on. And what happens when b squared minus 4ac greater than 0, equals to 0, or smaller than 0. So those are the things that you need to know. The second type of function that is kind of important over here is exponential and logarithm functions. So first thing first, what you need to know is, of course, for exponential function, you need to know the law of indices. So what are the law of indices? Basically, before that, what is exponential? Exponential means you have a to the power of x, for example. Right now we are using some constant a, but in the next chapter and so on, what you are actually facing is usually this Euler number to the power of x. But right now, let's stick to a to the power of x. And what is logarithm? So I will tell about the idea of logarithm later on when we enter into the logarithm function. But first, let's look at the law of indices. So of course, if let's say you have am multiplied with an, so if it is a multiplication between, okay, I might as well explain first what is a to the power of x. It means that you multiply a x times. So if let's say you see something like a to the power of m multiplied with a to the power of n, so what actually happens is you have a, let's just write this down carefully. So you have a multiplied with m times, and then you have a multiplied with n times. So from the index perspective, this will become a to the power of m plus n, because you can count how many times you multiply a by m times and then by n times. So in the end, you are just adding them up together. So similarly, if let's say you have a to the power of m divided by a to the power of n. So what happens is now you have a to the power of m divided by a to the power of n. So you can factorize out, like for example, how many n's of a you have. So in the end, the index will become a m minus n. So the third one, a power m power n again. So what will happen is you have a multiply together m times, and then you repeat this whole thing n times. So this repetition is n times. Of course, this will become m multiplied by n. So if you have a multiplied with b, both are power m, you can easily tell that based on all the illustration that I did before. So a times b times a times b and so on. So all this multiplication you multiply by m times. So then you can count individually how many a's. Of course you have m times, and you multiply with b m times together. So similarly, I suppose I don't need to illustrate anymore for this particular case. If you have a divided by b power m, then it will be a power m divided by b power m. So it's the same logic as before. Alright. So coming from the second property, this one, you know that when you are dividing a to the power of n, it actually becomes minus n. So this is one of the property. A to the power of minus m is actually 1 over a to the power of m. This comes from the second property. So now the next thing that you need to know is what happens if you have a fractional power. So this means that when you multiply all these things m times, you get back a. And we sort of see this property before. If you have square root x, for example, multiply with square root x, you get back x. So this means that when you have fractional power, basically this is the m root of a. Then what happens if you have some fractional n divided by n degree? So you just apply the same logic. So n will be at the bottom. So that's why your n is a root. And then you power m. So one thing that you need to know is that if a is the power of 0, this is equals to 1, provided that a is not equal to 0. So in a sense, a to the power of 0 is kind of a definition. But if you don't want to take it as a definition, you can also derive the last definition, so-called, starting from here, basically a power m divide by a power m, which is a power m minus m. So this is a power 0, and we know that this is equal to 1. So that's how you can derive the last one. So these are the list of all the law of indices that you need to know. Now let's look at what is logarithm. So if you have a to the power of x equals to b, for example, then the definition of logarithm is logarithm of base a, b is x. So take note of how the positioning of your a, b, and x in this particular case. So now let's look at the law of logarithm. Okay, let's start from the easy one. A to the power of 1 is a. So if you apply the same logic, apply this particular definition of logarithm, you will find that log base a is equals to 1. The second definition is coming from here. A power 0 is equals to 1. So log a1 is 0. So for logarithm, there are things that I think is better for us to prove it, and I leave it here. So there is this third definition, a to the power of log ab equals to b. So how do we prove it? So let's look at this particular proof. So this is kind of important. So you can okay, so perhaps I write down the proof here, since over here there's quite a lot of space. So you let a power x equals to b. Then log base a b will be equals to x. But x is equals to log base a b. So you can substitute this value of x back here. Therefore, a to the power of log base a b equals to b, which is what we need to prove. Okay, the fourth property is log base a xy. Notice how I sort of like close the bracket, is equals to log a x plus log a y. So let's prove this. So the proof of this comes from top here. So you have, for example, okay, so I need to think of, so I let a power m equals to x, a power n equals to y. Yeah, that should do. So by definition, then I would have log base a x equals to m, log base a y equals to n. And then from this particular index law,